Hello viewers, you are welcome to my YouTube channel. If you are new to this YouTube channel, kindly subscribe and also share this link to other groups of friends where you think it might benefit them. So our main focus for today, we are going to focus on mathematical induction. That is our main focus for today, mathematical induction. Presenting to you this tutorial, I'm your tutor, Patrick Divine. So we are going to cover a lot about mathematical induction for today. So make sure that you finish this full video so that you get the whole information about mathematical induction. Alright, so these are questions that come like this. So you find the question coming saying that prove by mathematical induction that this expression is equal to that expression there. Alright, so that is how these questions come. So I want you to pay much attention, understand what I'm going to teach, okay? You need to understand, So if you want to ask any question, so you can inbox me on this number on WhatsApp, 0975334778. That is my number. I'm Tutor Patrick Divine. That is my name. I'm your tutor, Patrick Divine. Okay, so that is the number there. Thank you. So let's solve this question. So we say solution like that. So this is our first question. So this mathematical induction has 3 steps, okay? It has 3 steps. So the first step is to prove that n is equal to what? Equal to 1. Is to prove that n is equal to 1. So n, it is the number of terms. N, it is what? The number of terms. N denotes the number of terms. Okay, so this is term 1, term 2, term 3, going that side, going, like that. So the first thing that you need to do, the first step that you need to do, you need to prove that n is equal to 1, or it might be n is equal to term 2, n is equal to term 3, like that, or any other term that you are given. Alright, so let's prove that n is equal to 1. Let's prove that n is equal to 1. We see if it is equal. So we'll start. So this is term 1. This is term 1. This is our first term. So we say this side will get the first term, like that. So we are saying that this whole part, we just get the first term. So then is it equal to this other part here? So we are saying that n is equal to 1. So mean that we are going to get this part, okay? We are going to equate this term to this part. Now where there is n, we are going to substitute 1. Since we are saying that n is equal to 1. So let's try to prove. So we say 1, open bracket. This, we have just put 1 here. Then we say 2 multiplied by 1, like that, plus 1. So let's prove. So that is 3 is equal to 1. Open bracket, that is 2 plus 1. Okay. That will be 3 is equal to 1 multiplied by 3, that is 3 is equal to 3. 1 multiplied by 3, that is 3. Like that. So we have proved that this side, the right hand side, is the left hand side is equal to the right hand side, like that. So meaning that it is true that what? That 1 is equal to, that n is equal to 1. So you write and say that since the right hand side is equal to the left hand side, therefore the statement n is equal to 1 is correct. The statement n is equal to 1 is correct. Okay, so let's try to prove if we use n is equal to 2, if it's going to be true. Let's try and prove if n is equal to 2, but you can just prove using one term. You can prove using one term, but we just want to see if n is equal to 2, it will be correct as well. So here we have these terms, this term 1, term 2, term 3. So it is getting the sum. Okay, this is term 2. It is getting the sum of this. That is term 2 right there. So we'll say 3 plus 7. So we'll say 3 plus 7 is equal to this. We said that n is equal to 2. So we'll put 2 multiplied by 2. 2, that is n. N is 2, like that. Then we'll say plus 1, like that. So let's check it out. So 3 plus 7, it is equal to what? 10. Then 2 multiplied by 2 times 2, that is 4. 4 plus 1, like that. Then it will be 10 is equal to 2, open bracket, 4 plus 1, it is what? It is 5. Then we say 10 is equal to 2 times 5, it is 10. So it is true that n is equal to 2, it will be like this. So that is how we prove. If you want to prove, you want to prove n is equal to 3, you can get this, you can get 3 plus 7 plus 11 is equal to that. Then you replace where n is equal to 3, like that. So that is step 2 now. Okay, so now step 2. On step 2, you need to assume. Okay, so this is step 2. Okay, the second step, I'll just write second step like that. Okay, so second step. So you need to assume. Okay, assume that n is equal to k. N is equal to k. The number of terms is equal to what? To k. So that is what you need to assume. So where there is n, you need to put what? You need to put k. This is what it is implying here. Where there is n, you need to put k. So you start from here, you copy starting from here to here. Okay, but remember, where there is k, you put what? You put where there is n, you put what? You put k. So we'll start from here. So we'll say it is 3 plus 7 plus 11 dot dot dot, open bracket, 4. Where there is n, we put what? K minus 1, like that. Then it is equal to n. Oh, we'll put k here. Okay, here we're going to put k, open bracket, 2 k, like that. Then plus 1. As simple as that. Okay, that is what to do. That is what to do. All right, so now that we have assumed that now that we have assumed that n is equal to k, the third step now. So from the second step, that is where you end. So now the third step, okay, the third step, I said that mathematical induction has three steps. So that was the first, this is second, and this is the third, the last one. Okay, so this one you need to prove. Okay, you need to prove that n is equal to k plus 1. So n is equal to what? Is equal to k plus 1. That is what you are supposed to prove. N is equal to what? To k plus 1. Prove that the statement is true for n is equal to what? to k plus 1. That is what you are supposed to prove in the third step. So what do you do from here? So what you do from here, you copy this statement starting from here to wherever it is, till here. Okay, starting from here to here, or should I say you copy this statement. Okay, you copy this statement. Yes, you copy the one that you have assumed from this point, okay, to this point. That's the first thing to do. The one that you have assumed from this point to this point here. So we have 3 plus 7 plus 11 dot 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 open bracket. Then we have 4k, okay, minus 1, like that. Okay, so I said that you copy from here to where? To here. That is what to do. That is the first thing to do on step 3. So you copy this, the one that you have assumed from here to here, okay, where there is an equal sign. So that's where you stop there. Then you need to add another term. You need to be careful, okay? So what you're supposed to do is to add another term. Now, adding another term, you're going to start from here to where? To here. Okay? You're going to start from here to where? To here. Alright. But where there is k, you need to put what? K plus 1. Where there is k here, you need to put k plus 1. Even here, you need to put k plus 1. That is the thing. I said, let me repeat this point again. If you miss this point, then you won't find the correct answer. So the first thing is to copy it from here to where there is an equal sign. So this is what we have done. Okay. Then the second thing to do is to copy from here to where? To here. But where there is a k, you put k plus 1. So what am I saying? I'm saying that this is the bracket. Starting from here, this is the bracket. Then there is 4, right? There is 4. Then where there is k, you put k plus 1. Where there is 4, you put what? K plus 1. That is what I'm saying. So mean that it is multiplying by what? By k plus 1. Like this. I've just removed k. I've put k plus 1. Then what remains is what? Minus 1. It is what? Minus 1, like that. Okay? It is minus 1. Then you are closing the bracket like that. Then this is the bracket like that. Okay? That is how it's going to be. Then from here there is an equal sign. So you put equal sign. So here where there is k, you put k plus 1. You put k plus 1. So if you see this k, it is multiplying with everything inside. So mean that it is multiplying with everything inside. Mean that this will be this other part will be like this. Okay? So we need to put 2 like that. Then k, we replace it by k plus 1 like that. Okay? So we just replaced k plus 1. So the what follows is plus 1. So what follows is what? Plus 1. Like that. Then we close the bracket like that. Like that. Are we able to see? Okay. So now, this statement, the way it is, this statement here. This statement. Okay. So this statement now, this statement which is right here. This statement which is right here, if you look at this one, with the one that we had assumed, so the one that we had assumed starting from here, reaching to the equal sign here, it is just the same as this one, starting from here, reaching here. Because 3 plus 7 plus that, from here, it's just the same as this one. Okay? And this one, it is saying that it is equal to what? It is equal to that part here, this expression, this side. This, the left-hand side, is equal to what? The right-hand side. That is what it's saying. So, for the rules of an equation, if here there is 2, here also there must be what? There must be 2 like that. Okay, if here there is what? There is x. Here as well there must be what? X. Equality. All right, so meaning that here this part is equal to that part. That means that we can even remove this part. We just put this part here. It is just one and the same thing. So what we are going to do, if you look at this one, since this one is equal to this, so even this one is equal to that. So we can actually remove this part, then we put this part here. So let's try to do that. So we are just going to replace this part by this part here. That is the thing to do. So we are going to put k, open bracket. Let me just write it from here. So that is k, open bracket. That is 2k plus 1. So we've just replaced this. What follows? It's plus. Okay, I've just replaced this part. So what follows is what? Is plus what? Plus 4. Okay, so plus what? Plus 4. So we can actually multiply 4 by everything. Okay, we can multiply 4 by everything. So say 4 times k. Okay, so say 4 times k, that is 4k. That is 4k. Then 4 times 1, that is what? That is 4. That is what? That is 4. Then here there is what? There is minus 1 is equal to, like that, is equal to, then here we can just copy it. This is k plus 1, like that. Like that. Then here it is multiplying with this 2. We can multiply it with everything inside. We can distribute. So 2 times k, that is 2k. Okay, then plus 2 times 1, that is 2, like that. Then there is plus 1 here, there is plus 1, like that. Something like this, something like that. Okay, so now here the statement, we need to, the essence of doing this is to prove that this part is equal to this part. Since there is an equal sign here, we said that if there is 2 here, there must be 2 like that. So we need to prove that this part, the left hand side is equal to the right hand side. That is what we are supposed to do. So now how can we prove this? How can we prove this? So let's finish doing this. So we have k, so we can actually multiply k times 2k. That is what? That is 2k squared. Okay, then k times 1, that is what? That is k, like that. Then there is plus. All right, this is actually 4k. That is 4. That is 4k. Then 4 minus 1. What is 4 minus 1? 4 minus 1, you find that it is what? It is 3, like that. Okay, you find that it is 3, then there is equal sign. You can actually do this. So if you try to add here, if you try to add 2 plus 1, so 2 plus 1, it is going to give you what? It is going to give you 3. 2 plus 1, it is going to give you what? It is going to give you 3. So you can actually say 2 plus 1, it is 3. Just write it. I just want to create more space. So 2 plus 1, it is what? It is 3, like that. Okay, so then this, if you look at this, everything, this one is in the bracket as well as that is in the bracket. So we can actually multiply k times 2k. So k times 2k, you're going to have 2k squared, like that. Then k times 3k, or k times 3, you're going to have 3k. Then 1 times 2, you're going to have 2k, like that. Then 1 times 3, you're going to have 3, like that. Okay, so what we are trying to make, we are trying to prove that this part is equal to this other part here. So let's try to add the like terms. So we have k plus 4k. K plus 4k, you're going to have 5k. So you're going to have 2k squared. K plus 4k, you're going to have 5k plus 3 is equal to, this is 2k squared. So 3k plus 2k. So 3k plus 2k, you're going to have 5k plus 3. So now, check it out. Is it equal? Are they equal? Yes, they are equal. So this is 2k squared, 5k, 5k, plus 3, plus 3. So meaning that the statement is true that k plus 3, the statement is true plus that n equal to k plus 1 is correct. So you just conclude to say the statement is true for n equal to k plus 1 since the left hand side, so left hand side is equal to what? The right hand side, like that. That is how you conclude. That is how you conclude. Okay, so let's do another example for more clarity. Let's do another example for more understanding. Let's do another example. So that was our first example that we had. Okay, that was our first example that we had. So let's do another example. So if you are new to this YouTube channel, don't forget to subscribe. Don't forget to subscribe to this YouTube channel because you benefit a lot from it. Okay, so our next question we have, so this is our next question. So we have 1 to the power 3 plus 2 to the power 3 plus n to the power 3 is equal to n to the power 3 to the power 2. It is equal to n to the power 2, open bracket, n plus 1, close bracket, to the squared, then this whole thing divided by what? Divided by 4. That is the question that we have here. That is the question that we have here. So if you remember, I said that the first step, you can prove for the first term or for the second term or for the third term. So let's try to prove for the first term. The first term, it is this one. So the first term, it is what? 1 to the power 3. It is 1 to the power 3. Okay, so this is 1 to the power 3. Is it equal to? So we said that you need to prove that n is equal to what? N is equal to 1. That is the first step. So let's prove if n is equal to 1. So this is the first term, that is 1 to the power 3. Okay, is it equal to, here we put 1, so it's going to set 1 to the power 2, open bracket, 1 plus 1, then to the power 2, divide by 4. Is it equal to this? So 1 to the power 3, it is just the same as 1, like that. Just do 1 to the power 2, it is 1, open bracket, 1 plus 1, that is 2, to the power 2, divide by 4. So 1 is equal to, this is just 1 multiplied by what? 2 to the power 2, it is just 4, like that. Then divide by 4. So you can actually divide 4 like that, then what you are going to remain with, it is 1, like that. So therefore the right hand side, the right hand side is equal to the what? The left hand side. So the statement is true for n is equal to 1. The statement is true for n is equal to 1. So you can even try for the second term if you want. If you can even try for the second term if you want. Okay, let's try if the second term is true. let's try if the second term is true. So the second term here, it is what? 2. The second term. So n, it represents the number of terms. So let's try if the second term is true. So let's say the second term, this is the part of the second term. So we are adding these two. Okay, so we are adding 1 to the power 3 plus 2 to the power 3. Is it equal to this part? If we say n is equal to 2, so n, so we'll just put 2 to the power 2 there, open bracket, 2 plus 1 to the power 2, then over 4. That is what it says. So here we are going to say 1 to the power 3, it is 1, then 2 to the power 3, 2 to the power 3, you find that it is what? It is 8, like that. Then it is equal to 2 to the power 2, it is what? 2 to the power 2, it is 4. Then open bracket, 2 plus 1, that is 3, like that. Then you are squaring it over what? Over 4, like that. Then this 4 can go like that. Okay, so you have 1 plus 8, it is what? It is 9, equal to, this is just 3 to the power 2. So 3 to the power 2, it is 9, like that. So the statement is true that n is equal to 2. The statement is true that n is equal to 2. That is the first step. Okay, that is the first step. So that is this. That is how it is there. So now we are going to step 2. So step 2, which is the second step. Okay, so the second step is assume. Okay, assume that n is equal to k plus 1. Assume that n is equal to k plus 1. N is equal to k plus 1. Oh, I mean n is equal to k, that is step 2. That is step 2. Okay, n is equal to k. That is how you write. Assume that the statement is true for n is equal to k. So n is equal to k, you copy just the same way that we did in the previous questions. So you copy starting from here to where? To here. Okay, but where there is n, you put what? You put k. Where there is n, you put k. So we say 1. Okay, we say 1 to the power 3 plus 2 to the power 3 plus n to the power. So where there is n, we put what? We put k. So we say k to the power 3. Right? K to the power 3 then is equal to k there. Okay, k to the power 2, open bracket, k plus 1 to the power 2, like that. So that is how we assume. That is how we assume. So now we need to write the third step. Okay, so the third step, we prove, okay, the third step we prove that n is equal to k plus 1. We prove that the statement is true for n is equal to k plus 1. So what we did in the previous example that we had, so we copied from here until we reached here. That is the first thing. So we are going to do the same. So 1 to the power 3 plus 2 to the power 3 plus then k to the power 3. Then the second thing is to add the second term. So the second term is starting from where? From here. Okay? The second term is starting from where? From here to where? To here. But where there is k, put k plus 1. Where there is k, you put what? K plus 1. So starting from here, we are going to say this is k. So we put k plus 1. So meaning that it's going to be k plus 1, but since it is squared, it is to the power 3, so we put power what? Power 3 like that. Then is equal to, this is what is following, it is equal to, this is k to the power 2, so mean that it's going to be k plus 1 to the power what? To the power what? To the power 2. Then this is another bracket here. Okay, we say this is k. We replace k by k plus 1. So this is k plus what? Plus 1. So we just replaced k plus 1. What is remaining is, it is what? Plus 1 again. It is plus 1 like that. Okay, it is plus 1 like that. As simple as that. So now, the thing that we are supposed to do after this, if we look at this on the one that we had assumed, this part is equal to this part. That is what it's saying. So this part, it is the same as what? As that part here. This part, it is the same as this. Okay, it is the same as this. So we are supposed to replace this by that, since this one is equal to that one. So we are going to say this, we're just going to replace it by that. So that is k to the power 2, open bracket, k plus 1 like that, to the power what? To the power 2. Then what follows here, it is what? Plus k plus 1 to the power what? K plus 1 to the power 3 like that. Then it is equal to, like that, it is equal to, so we just copy this. This is k plus 1, okay, k plus 1 to the power 2 like that. Then this, you just write it. So this is k, okay. Then there is 1 plus 1. 1 plus 1, it is what? It is 2 like that. 1 plus 1 is 2. Oh, I forgot to square it. I forgot to square it. This has to be squared. Has to be squared. Since here it was squared like that. Since here it was squared like that. So this has to be squared. Alright, so we go on. So we have to prove from here, we have to prove that the left hand side is equal to the right hand side. The left hand side is equal to the right hand side. So if you look at here, this is what? This is k plus 1 to the power 2. This is what? K plus 1 to the power 2. So these two, they are equal. These two, they are equal. Actually, I should say this part was supposed to be over 4. So it was supposed to be what? To be over 4 like this. I'm so sorry on this one. Even this whole part is supposed to be over 4 like that. If you look at it the way it is. If you look at it the way it is here. So this was supposed to be over 4. Okay? It was supposed to be over 4. So I just said that this part is equal to that part. So I just copied this part and had to put it right here. Okay? I had to put it right here since it is equal to this. So this one, I just put over 4 like that. Then, after copying from here by adding k plus 1, this is it. Then, this is the whole thing here. We had replaced where k squared is, we had replaced it by k plus 1 like that. Then, like that, then it is what? It is over 4. That is why I have put 4. I'm sorry for that mistake that I had made. I just forgot. Okay, so we are still okay on this one now. So from here now, since this part as what? This part, the way it is, this part here, it is just a fraction. This one, it is just a fraction. Okay, so you can just put over what? Over 1 like that. Just this part on the left hand side. So you just look for a common factor. So that is what? That is 4. That is 4. Then 4 into 4, it is 1. 1 times everything which is here, it is just going to give you k squared, open bracket, k plus 1 to the power 2 plus 1 into 4, it is just going to give you 4. 4 multiplied by that is going to be 4 times k plus 1 to the power what? To the power 3. Like that. Like that. Then here you just say equals to, this is the part here which is k plus 1 to the power 2, open bracket, then this is k plus 2 to the power 2 over 4, like that. Okay, so from here now, from here where you are, from here, so you need to get rid of 4, since this is just an equation. Okay, this is just an equation. This is just an equation. So if you multiply this by that, it is going to be the same thing. So you can even it will reach where you're supposed to divide 4 by 4, and it will give you 1. So to get rid of 4 from here, you just multiply this part by what? By 4. Okay, even this part by what? By 4. So mean that this 4 will cancel that 4, as well as this 4 will cancel that 4. So meaning we are going to have, here we are going to have k squared, that is k plus 1, okay, to the power 2 plus 4, open bracket, k plus 1 to the power 3, like that. Then is equal to, since these 4 they are gone, so you are going to remain with k plus 1 to the power 2, then open bracket, k plus 2 to the power 2, like that. So this is the expression that we have here. So now here you can factorize this. You can factorize this. Okay, so what we are trying to do is to make this part equal to this part here, is to make this part equal to this which is on the right hand side. So what you do here, you just have to factorize. Since this one there is k plus 1 here, there is also k plus 1. If you have something like this, you have 2x to the power 2, then there is plus, let's say there is 4, then there is 4x to the power 3, like that. Okay, so since here they are common, these are common. Since these are common, so what is common here? If you want to factorize, you can factorize as 2x is common, 2x squared is actually common, 2x squared is common. So 2x is squared into that, it will give you 1. Okay, 2x squared, it will give you what? It will give you 1 plus 2x squared. So 2 into 2, it will be what? 2. Then this x squared will cancel this. There are 3x. There is 3x. Okay, so mean that there's going to be what? 1x remaining. So it is going to be like this. So it is going to be what? Like this. So this is the same way that you are going to do with this part. You are going to factorize. You are going to factorize, since here these two, they are common. Since here these two are what? They are common. Right here they are common. So what you do, you're going to factorize. So what is the common factor here? What is the common factor? So the common factor is k plus 1 squared. So the common factor, the one that can enter into this without leaving a remainder, is what? Is k plus 1 squared. This is what can enter in both. Okay, so if k plus 1 enter in this, okay, in this part here, so this will just cancel that. Okay, so this one will go into this one, it will cancel this. Okay, So what you're going to remain with what? It is what? It is k. So what you're going to remain with, it is k to the power what? To the power 2, like that. Then plus this, it is going to enter into this how many times? 1 time, and you will remain with what? Another k plus 1. So there is 2k plus 1. There are 2 here. There are 2. Then here there are what? There are 3. So mean that it is going to enter in here 1 time, and 1 will remain. 1k plus 1 will remain. 1k plus 1 will remain. So what we are going to have? We are going to have 4 multiplied by what? By k plus 1. K plus 1, like that. That is what you are going to remain with. Like that. Okay? That is what you are going to remain with. You can even see here, you just copy this one. Don't tamper with this. You can just copy this one. Since it is like this, squared, open bracket, k plus 2 squared, like that. Okay? So what you're trying to do is to make this part equal to the right hand part. So here, we can actually multiply this. We can actually multiply this so that we have the answer there. So here, since we know that this is equal to this, so this part here, it is already equal to that part. This is k plus 1 squared, k plus 1 squared, so we don't need to tamper with it. So that is what to do. So this is k plus 1 to the power 2, like that. Then open bracket, this is k squared, that is k squared plus 4 times k. 4 times k, you're going to have 4k. You're going to have 4k, like that. Then 4 times 1, you're going to have what? 4, like that. Okay, is equal to what? Is equal to k plus 1 to the power 2, open bracket, k plus 2 to the power 2, like that. Are we together? I hope we are getting it. I hope you are getting it. From here now, we know that this is a quadratic equation. This is a quadratic equation. Okay? So since this part is just the same as this part is equal to this one. So we don't need to tamper with it. So what we are going to tamper with, it is this part here. It is this part where you find the product, the sum, and the factor. Okay? So you can find the product, sum, and the factor for this one. So if the product is what? It is what? It is 1 times 4. That is the product. You find that it is what? It is 4. Okay? So now you need to find the factors. You need to find the factors. The factors, they are numbers. When you multiply them, they will give you the what? The product. And when you add them, they will give you the sum. So this is the sum. Okay? So that is the sum. The sum is what? It is equal to 4 as well. So when you we need to find the factors. When you multiply the two factors, they should give you what? They should give you 4. They should give you the product, which is 4. And when you add those two factors, they should give you what? They should give you the sum, which is 4. So what are those? So you find that there is 2 times 2. Okay? So 2 times 2 will give you the product 4. And when you add 2 plus 2, it will give you what? The sum. So mean that the two factors are these two. If you try to solve this quadratic equation, you find that the answers are going to be x are going to be k plus 2 and what? K plus 2. Since these are the factors that we had found. So we're going to have these as the factors. Okay. And these two, these are just the same. These two, they are the same. You can even write them like k plus 2 to the power 2, since they are 2. You can write them that way. You can write them that way. So mean that the answer is what? Is this one here. Is this one. K plus 2, k plus 2 to the power 2. So mean that we are going to say this is k plus 1 to the power 2 plus the answer that we had found. So the answer is what? K plus 2 to the power 2, like that. So is it equal to this side? Is it equal to this side? So this side is k plus 1, okay, k plus 1 to the power 2, then k plus 2 to the power 2, okay. So I think for those that are confused, I'll try to solve this quadratic equation so that you should understand. So this is the quadratic equation that is there. This is the quadratic equation. There are those that are confused. I know there are those that are confused, but there are those that have understood that you find this answer, okay, that you find this answer. So this is k squared plus 4k plus k. So k squared plus 4k plus 4. So this is the answer. So this part is equal to that one. So you say the statement is true for k is for n is equals to k plus 1, since the right hand side and the left hand side are equal. So master this, I want you to just take note of this. This is k squared plus 4k plus k. I want to solve this quadratic equation so that you know what I am talking about. So I'm just trying to create space here, okay. Just trying to create space here. So we said that quadratic equation was k to the power 2, okay, k to the power 2 plus 4k, k plus 4, it is plus 4k plus 4. This is the quadratic equation. So if you want to find the product, you multiply the coefficient of k times the coefficient of what? Of c. So that is 1 times 4. That is what? That is going to give you 4. Then the sum is going to be this. The sum, it is the one on the middle, the coefficient of b. So that is 4. Then the product, or the factors, okay, the factors, they are numbers that you can multiply, add to get the sum and the product. So we said that the factors, they are 2 and what? And 2. So meaning that we are going to solve it like this. So it is going to be k squared plus, you get the 2 there, 2k plus 2k plus 4, like that, okay. Then here you now factorize here. So what is common here? It is what? It is k. So k here you have k plus k, cancel that k, you have 2, like that. Then open bracket. Also this is you're going to put plus. What is common here? What is common is 2. 2 can go in both without leaving a remainder. So 2, you remain with what? K plus 2 into 4, you're going to remain with what? 2 into 4, it is what? It is 2, like that. Then you're going to get this plus that. So you're going to get k plus 2, like that. Then you just get one of these, just one of that. So that is what? K plus 2, like that. Then this, I said that you can actually write it as k plus 2 to the power 2, since these are 2. If you're multiplying x times, if you're multiplying, let's say, let me put y times what? Times y. Y times y, it is what? Y squared, like that. This is what I'm saying. When you multiply this part times that part, you are going to have a square like that. So that is how you prove that, okay. That is how you prove that. So we have proved that the statement is true for n is equal to k plus 1. That is the third step, okay. Let me just do the last question. Let me just do the last question so that you understand Very well. Let me just do the last question. Let me just do the last question so that you get more understanding on this. So the last question, this is the last question, okay? The last question. So the last question, we have 1 plus 2 plus 2 to the power 2 plus dot dot dot. We have 2 to the power n minus 1 is equal to 2 to the power n minus 1, like that. Okay, so this is to the power, this is not power, like that. Yeah? So that is how the question is. So the first step is to what? To prove for n equal to 1. So just prove for n equal to 1, since we know how to do it. So that it will be 1 is equal to 2 to the power what? To the power 1 minus 1, like that. Okay, 2 to the power 1 minus 1. Then, oh, sorry, I've just gotten this. So, but is to get this part here. Is equals to 2 to the power 1 minus 1, like that. Then to be 1 is equal to 2 to the power 1 is just 2. 2 minus 1, it is just 1. So mean that it be 1 equal to 1. So the statement is true for n is equal to 1. So that is the first step. I'm doing it fast because I know that you have understood. I know that you have understood. So the second step, okay, so the second step here, the second step is to assume that n equal to k. Okay, so n is equals to k. That is the second step. So we'll copy this. That is what to do. So that is 1 plus 2 plus 2 to the power 2 plus 1 dot dot dot, or plus dot 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 plus 2 to the power k. Okay, where there is n we put k. Okay, k minus 1 is equal to 2 to the power k minus 1. So that is the second step. That is the second step. I hope you are getting it. Then the third step, okay, the third step is going to be, you're going to copy this. Okay, so you're going to prove the statement, to prove that the statement is true for what? For n equal to k plus 1. That is the third step. Okay, that is the third step. So let's prove for n is equal to k plus 1. So you copy this one that you have assumed from here to here. That is what I said. So it is 1 plus 2 plus 2 to the power 2 plus dot 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 2 to the power k minus 1 is equal to 2k, 2 to the power k, sorry, it's 2 to the power k, then there is minus 1, like that. Okay, so now what to do? Oh, no. So it's to copy from here to here. That is what I said. So pardon my motion, I'm too fast. Okay, so it's to copy from here to here. So you copy from here to here. This is it. Then you add another term. You add another term, and another term starts from here. Start from here to here, but where there's k, you put k plus 1. So that is going to be 2 to the power k plus 1. Then what is remaining is what? Minus 1, like that. Then it is equal to 2 to the power k plus 1, then minus 1, like that. Okay, that is what to do. So you know that this part is the same as that part there. Okay, it is the same as that part there. So this part, okay, this part is the same as that part up here, the one that we have assumed. And the one that we have assumed, actually I should say this part to here, okay, to the equal sign. So this part to here, this part to here, okay, is actually equal to this part here. So mean that this part we can replace it by that. So that is going to be what? 2 to the power k. I'm copying this. 2 to the power k minus 1. So what is going to remain? We just replaced this by that. Then what is going to remain? It is plus 2 to the power k. Here, this is 1 minus 1. 1 minus 1, it is just 0. So you can put 0 if you want, but you can just leave it like that. Okay, then what follows, since we have just gotten this, then here we say equals 2 to the power k plus 1 like that, then minus 1 like that. So this expression that we have here, this expression that we have here, what do you do? So you make this part equal to that part. It should look like the same as that. So what do you do here? So these ones, they are like terms. These ones, they are like terms. These ones, they are like terms. So you just bring them together. So this is 2k, 2 to the power k. Okay, this one is positive, 2 to the power what? To the power k like that. Then this is minus. So you just say minus 1 like that is equal to 2 to the power what? To the power k plus 1 minus 1 like that. Okay, 2 to the power k minus 1 like that. So this one, you can factorize this part. You can factorize this part. Okay, you can factorize this part here. You can factorize it. So if you want to factorize it, I said that when you're adding 2x plus 2x, okay, 2x plus 4x or plus 2x, let's say, since we have common numbers, let's use plus 2x like that. So if you are trying to factorize, if you want to factorize, let's say there is power 2 like that. Okay, let's say there is power 2 like that. So if you are trying to factorize, you're going to say 2, you're going to have x like that plus what? Oh, I'm saying you're going to have 2, let's say 2x, you're going to have x plus 1 like that, if you want to try and factorize. So the same way that you are going to do it here. So here we have what is common here? What is common? It is 2. 2 to the power k is common. So 2 to the power k is common. So what we are going to have here, 2 to the power k, it will you just go in this one time. So it is 1, then plus again this one to be what? 1 like that. Then it's minus 1 like that. Then it's equal to 2 to the power k plus 1, then minus what? Minus 1 like that. Okay, so now 1 plus 1, that is 2. So that is 2 to the power k. So this is open bracket 2 like that, minus 1 like that. Then is equal to 2 to the power k plus 1 minus 1 like that. Okay, so now when you reach here, this is just the same as 2 to the power k. It is multiplying by that. 2 to the power k, it is multiplying by this. So this is just the same as 2 to the power k when it is multiplying by, so I should just say this, it is multiplying by 2 like that. So this is 2 to the power k. It is this one is just the same as 2 to the power 1 like that. just the same as 2 to the power 1. And when you are multiplying same numbers with powers, so you add powers, so mean that it is going to be what? 2 to the power what? To the power k plus what? Plus 1. We said that when you are multiplying, you add the what? You add the powers. Then what is remaining here? What is remaining is what? It is minus 1, like that. So is it equal to this part? So this part is saying that it's 2 to the power k plus 1 minus 1. So is it equal? Yes, it is equal. Yes, it is equal. So meaning that we have proved that this is equal. So the way you conclude, you just say, since the right hand side is equal to the left hand side, therefore the statement, okay, the statement is true for n is equal to k plus 1, like that. So that is how you conclude. So I hope you've understood how to prove questions of mathematical induction. So in the next video, we are going to do other questions that I haven't done, and they are important. They also come, so you need to understand all those questions. So if you are new to this YouTube channel, kindly subscribe and comment, and also share the link so that others can also benefit. Thank you for watching. I've been your tutor, Patrick Divine. Continue having a good evening.